Hello, Algebra 2. So we're moving right along in Chapter 5, which is all about rational exponents and radical functions. And here we are with 5.5 performing function operations, and we're going to be doing it too, specifically the rational exponents and radical functions here in this section. And the performing operations, the operations we're talking about is the just familiar ones to us: add, subtract, multiply, and divide functions. All right, so before we get into that, let's do a quick little cartoon. So this one's a foxtrot cartoon. If you're not familiar with this, it's about a family. So these are a sister and brother. He's the older brother, and she says, can't do these math problems. Why am I so stupid? If 2x plus y equals 60 and x plus 2y equals 75, solve for x and y. How the heck do I figure that out? Well, if two shirts and a sweater cost $60 and a shirt and two sweaters cost $75, what does each item cost? She says, well, the shirts are $15 and the sweaters are $30. Duh. He says, well, you aren't stupid, Paige, just weird. Come back. You still haven't told me how to solve the problem. So she's, if you're not familiar with this, she's a very big shopper. She loves shopping and finding deals. So he was just kind of taking that problem and putting it into a context she understood and was able to do that correctly. Okay, so on page 145 in your notes, you want to look at this core concept with me. Specifically, what we want to need to see on this core concept is the notations for the addition, subtraction, multiplication, and division, how that's going to be shown to you. So you're going to be given two functions. Typically, they're going to be called f and g, like f of x and g of x, as you can see here. So when you're adding them, it might look like this. It might say f plus g of x, or maybe saying f of x plus g of x. This is subtraction, f minus g. F next to g right here means f times g, and f over g means f divided by g. So there's two different ways that they might show it to you. They might show it to you like this. They also might show it to you in this way: f of x plus g of x, or f of x minus g of x, or f of x times g of x, or f of x divided by g of x in a fraction form like that. So either way, it means the same thing. It means addition here, subtraction, multiplication, or division if it's in fraction form like that. So that just tells you what to do with the operations. And so if here's our example problem right here, you have a function f of x is 5x and g of x is x plus 2. Now this is a very simple one. Ours are going to be a little more difficult than this. When it just says, okay, now add them, you're just going to be adding like terms, subtract them. Subtract by doing addition, basically the inverse property here, where you're going to distribute the negative in and then combine like terms. Here you're multiplying, so this would just be a distributive property for multiplying, and then dividing, there really isn't anything to do because you can't really divide those. You just leave them the way they are. All right, so let's get into our problems there on page 146. Okay, so on page 146, for 1 through 4, it's asking us to do a few things here. So we're going to read this up here. So it says we're going to find f plus g and f minus g. So we're going to do that to both problems and state the domain of each. Just ask for domain, not range, so just domain. That would be what the x would be for the x-axis on a graph. Then evaluate the result for f plus g and f minus g for the given value of x. So it gives you a number for x right here. On this one it's negative 1,000. Over here it's a negative 1 on number 2. So the first thing to do is just to be adding them together and then subtracting them together. So let's start with adding on number 1. So we're going to do our f plus g of x. That means we're going to multiply, or not multiply, add this function here, the f of x function, and this g of x function here. So we're just going to say this one plus this one. That's all we got to do, just write that down first. So there's our f function, here's our g function, we are adding them together. So since they are, and we learned this in radicals, if we have a like radical here, we can add the numbers in front of those radicals. So these are both cube roots, so we can add the negative 1/2 plus the 9 over 2, which actually is going to be kind of subtracting since they're different signs. They are already common denominators with 2, so we can just take 1 away from 9. That gives us 8 over 2. So we're going to see 8 over 2 with the cube root of x, and then 8 over 2 would just be 4. So our answer for this one, for f plus g, is 4 cube root of x. So that's the addition of f plus g. Now we'll do the subtraction. So we're going to subtract them, kind of the same thing. We're just going to put a minus sign in between them instead of a plus sign. So now we just have, here's our f, here's our g again. Now we're going to subtract with the minus sign here. So same thing, we can still put these together. We're just going to do negative 1/2 minus 9/2. So really this is now going to be negative 1 and a negative 9. So that makes negative 10/2. So on this one we'll have a negative 10/2 with the cube root of x. And so negative 10/2 would be negative 5. And so that would be our result for the subtraction of f minus g. Okay, so now, so we got these done now. The results are here for f plus g, f minus g. It says to do, the next thing here is stating the domain. Well, we need to remember about the domain that these are cube root functions which they go everywhere both directions. So since they go everywhere in both directions, that does mean that they're all real numbers. Actually, they'd be all real numbers for both domain and range. So this is going to be all real numbers for both of these. So the domain of f plus g is all real numbers, and the domain for f minus g is also all real numbers. Because they're cube root functions, it's like the snake going across the graph, if you can think of it that way and visualize that. Okay, now the next thing says to evaluate. We're going to use these numbers here, the negative 1,000. We're going to plug that in for x in both of these and just evaluate that. So for the top one here, the f plus g, when we do that, that will end up being 4 now times the cube root of 1,000, or negative 1,000. So we're just replacing the x with negative 1,000 here. And so the cube root of negative 1,000, we should know that. That's a perfect cube. That'd be negative 10. So this is really going to be 4 times negative 10, which the result would be negative 40. And then the next one, we're going to replace the x here also with negative 1,000. So it's negative 5 times the cube root of negative 1,000, which we already saw that's negative 10. So now it's just going to be negative 5 times negative 10, which would be positive 50. So there's our evaluations now of f plus g and f minus g for this number of negative 1,000. Okay, so for number 2, we're going to do the same thing. In fact, this one you might want to do it by yourself. It should be pretty easy as far as these two functions. They're just kind of polynomial functions. So just adding them together, be combined like terms, subtracting them. You're going to be kind of changing the signs of this one on g here to their opposites. So you might want to stop the video and do that for a minute, and then start it again. Okay, so let's just go through it. F plus g first. So we're going to add these together. So we're just going to say this is our f, and we're going to add it to the g. So I'm just going to put a plus. Here's my f function here plus the g function, and it's just combining like terms. So for x squared, I got a negative 1 there and a negative 3 here. It makes negative 4. The x ones, I got a negative 3 and a positive 6. That makes a positive 3x. And then I also have a plus 8 to include. So there's our final answer here for this function. The result would be negative 4x squared plus 3x plus 8 for adding these together, just combine like terms. F minus g, our next one, we're now just going to put a minus sign here instead of a plus, and for this one I'm going to put a parenthesis around g here because I'm going to have to distribute the negative in when it's a minus sign. So it didn't affect it when it's a positive, but when we're going to put a minus here, we're subtracting the whole function, so it will affect both terms in the function. So we need to see it kind of like this. Here's our f function minus the g now is in parentheses, and we have to distribute our negative into there, changing both of those signs. So it'll look like that there. I put it in red. So now I'm going to change really this into a positive, and now it's just back into addition again. So I can change the subtraction to addition, and then this 6x becomes negative 6x, positive, or this becomes positive 3x squared, and now I just combine like terms. So for x squareds, we got negative 1 there, positive 3. So that'll be a positive 2x squared. Negative 3x, negative 6x makes a negative 9x, and then we also have that plus 8 again. So now our result will be this, 2x squared minus 9x plus 8 for the f minus g. Okay, now we look at the domain and range. Well, these are polynomial functions, so let's say they're both quadratics. X squared is the highest exponent in both of them, so these would both be parabolas. This would be opening down on this one. In fact, they're both opening down because our leading coefficient here is negative. So it'd be they're both u-shapes opening down, which in that case, This would be here, opening down. This one actually now is opening up for this one. So we can see the domain and range are really from the f plus g and the f minus g. So this one is a polynomial, or I should say a parabola that's opening down, and this is a parabola that's opening up. So they both have the domain of all real numbers because they're going both directions everywhere on the x, everywhere right, everywhere left. So all real numbers for both of these as well, because of the fact they're quadratics and they're opening up and down. Now we need to evaluate for this number, -1. We're going to take -1, plug it into the x in both places in both of these new functions that we just got. So starting with the f plus g, we will plug -1 in for x. So there it is, -1 goes into where x was being squared, and -1 is here. So -1 squared is +1, and that will make this a -4 term here. This will make this a -3 term there. So it'll be like that, -4, -3, and a +8. And we just combine those numbers. That makes -7 plus 8. So our number there is just 1. So the evaluation of f plus g for the -1 is going to be 1. Another way you might see this, the -1 might be here. See where it is over here where this x is? F plus g of x. If it's at f plus g of -1, then that means to evaluate for -1. Do exactly what we're doing, and we would get +1 for that. And then this one, same thing. We're going to put -1 in both places. So this is going to, again, be +1 here. So this term will be +2. This will be a +9 term here in the middle with that +8 at the end. So just 2 plus 9 plus 8, adding those three numbers together gives us 19. So that's the evaluation. Again, we could see a -1 go here. You might say f minus g of -1, and that means just to do this. Okay, number 3 is another one you might want to try on your own. Again, it's just got some polynomial functions here, so these are pretty easy to do with adding them and subtracting them just like number 2. So you want to stop the video and just try this problem. I would try the whole thing, see if you can get the whole thing correct, and then just check your work and answers as I go through it. Okay, so here we are, starting with f plus g again. So f plus g, we're going to add these two functions together. The f right here, 4x to the third plus 12, and we're going to add it to the g right here. Now notice I didn't put any parentheses. I don't need to when it's a plus because that does not affect anything over here. I'm just going to be combining like terms. So I have some x to the third that we can put together right there. That'll make 1x to the third. And there's only 1x squared, so that's going to be in our answer. And then the 12 and the 9 will combine together. So our answer for this one is the 1x to the third, or just x to the third, plus 2x squared, and then plus the 21. So that's going to be our result for f plus g. And then next, f minus g, subtracting them. Here's where this plus will now change to a negative, but we're going to need to put the g function here in a parenthesis to show we have to distribute this negative now into this function here and change all three signs. So that's what we have to do when we're subtracting. We learned that back when we were doing the polynomials in chapter 4, and even algebra 1 taught you that. So distribute negative into here. So now this becomes our 4x to the third plus the 12. I'm going to change this negative to a positive just so I know that I'm going to be just adding and combining like terms. And then all of these are going to change their opposites. This becomes negative 2x squared, positive 3x to the third, and this now is negative 9. And so the x to the third ones are both positive now. That's 7x to the third. And now the x squared one is a negative 2x squared, and then the 12 minus 9 will subtract those numbers. And here's our result, 7x to the third minus 2x squared plus 3. So there's the result for f minus g. Now for the domain of these, the cubed functions, we need to realize, we know cube root, we were just talking about cube root, and that's the snake going across the graph kind of like this. But this is also a snake going across the graph, but it's kind of slithering up and down. So it's kind of doing this kind of thing. So it still is going everywhere, left and right. It will eventually go everywhere slowly, but surely go everywhere left and right. So that means your domain is still going to be all real numbers for both of these on the cubed functions. So all cubed functions, again, will have the domain definitely be all real numbers. The range will be all real numbers as well because it is going up and down everywhere as well. But we can say all real numbers for domain on both of these. Now you might think, is it always going to be this? It won't always be this. We'll see on some of the ones in here coming up, they won't be. Next would be evaluating for x equals 2. That's the number we're going to plug in here. And so you just plug it into both places. And so it's going to be a 2 to the third power plus 2 times 2 squared, and then the plus 21 there at the end. So 2 to the third, that's going to be an 8 for this first number. 2 squared is 4, and times 2 is another 8, so 8 plus 8, then plus 21. And so those three numbers added together give us 37. So our 37 is our evaluation. And again, like I said, you might see, I didn't put it over here this time, I just put f plus g, but you might see that little parenthesis next to it with a 2 in front, or 2 inside there, to also kind of notate the evaluation for this number 2. Plugging 2 into this one, we're going to see, again, we're going to cube it here, and we're going to square it here again. So this is going to be 8, but we got to multiply 8 times 7. Now it's going to be 56 for this first number. And this will be a negative 8 this time here, and then plus the 3. So 56 minus 8 plus 3. We'll subtract those first two, then add 3. That's going to give us 51. So 51 is that one. All right, coming on to number 4, starting with the f plus g. So f plus g again. So we're just going to add this function and this function. It has the radicals in there. They're both fourth roots. So we will be combining like terms. The like terms are here with fourth roots. Those can combine. Your 5 and this negative 3 here can combine. And then obviously we have the positive 1 and negative 2. Those can also combine. So since these are the same root, they're the fourth root of x. They're like roots, we can call that. So 5 minus 3 is 2. So that's going to be a 2 fourth root of x, and then minus 1, because we're going to see a 1 and a negative 2 becoming negative 1 here. F minus g, again, is just going to change this. I'm also going to put this in a parenthesis, put the g function in that parenthesis, since that's the second one. Always just the second one goes in a parenthesis when we're subtracting. So now it'll look like this here. Here's your f minus the g function in a parenthesis, and we're going to distribute this negative into here. I'm going to change this to plus again, just to show that now I can combine like terms again. So our minus sign becomes a plus, and now this becomes a positive 3 in front of the fourth root of x, and this is also a positive 2. So again, we can combine like terms with our fourth root of x here. It's going to be a 5 plus 3, so it's going to be an 8 now in front of the fourth root of x, and then 1 plus 2 will give us a 3 there at the end. So 8 fourth root of x plus the 3. So as you're seeing, these aren't very difficult to do, the adding subtracting functions. As long as we just know that we can add and subtract these like radicals, and we're not changing root signs or anything, we're just changing the numbers in front of them. For as far as the domain, okay, so on this one we have a fourth root, and a fourth root is an even root, which we know these ones only go one direction on the graph. These are like the frisbee toss. All even roots only go one direction. So in that case, it can't be all real numbers. It's only going one direction, and these are both going off to the right. And the reason why we know they're both going off to the right is because the x underneath here is not a negative x. If this said negative x, then it would be going off to the left. So that's important to know, that we're going to be seeing these go to the right, which is in the positive direction, and they're both going to be greater than or equal to basically whatever the h number is. So in this case, our h number for this one would be 0, because there's no h number in this one or this one. So they're both going to be 0, so it's got to be greater than or equal to 0. That's what we're going to see here. Our domain is going to be greater than or equal to 0. So it's going to start at 0 on the x for your starting point. It'll be a negative 1 for the y, but we're concerned on domain of where the x is going to be. And that's always the h number, which would be underneath here with x. Since there is nothing else, there's not like x plus or minus some other number underneath here, so it's always 0. And now to evaluate for the 1, the 1's going to go inside here. The fourth root of 1 would be 1, so that's pretty easy to do. Fourth root of 1 is 1, so this really is going to be 2 minus 1. That's all that one is. And that gives us 1 for the evaluation of our f plus g. And same thing here, plug 1 in. So again, that's going to be 1 times 8, which is just 8 plus the 3. So that's going to give us an 11 for that evaluation for f minus g. All right, let's take a break and do a little joke of the day. What's the difference between chopped beef and pea soup? You heard this one before? What's the difference between chopped beef and pea soup? Well, here it is. If you were wondering, The difference is everyone can chop beef, but not everyone can pea soup. That's the difference. So I hope that didn't gross you out too much on that one. Okay, so here we are back on page 146, looking at 5 through 8. So the 5 through 8 problems are pretty much the same as 1 through 4, except now we're multiplying and dividing with the functions instead. So we're still going to be stating the domain. We're still going to be evaluating for a given value. As you can see, it's negative 64 on 5 here. But we need to multiply the functions first. F times g, or f next to g is just f times g, and f over g means dividing the functions on this one. So starting off with multiplying, we're going to do f times g, so that'd just be the negative x to the third times this g function right here, 2 cube root of x. So we're going to multiply those together. So what we need to do is we need to get them to either be the same thing, either be both radicals, or they need to be both exponents. So I'm going to get this to be both exponents here, and I'm going to change the cube root of x back to a fraction exponent. So we're going to keep this the same in front. The negative x to the third is still here, and then 2 is still there, but now this cube root of x is now x to a 1/3 power. And so now that lets me be able to kind of multiply these together. So that's like negative 1 times 2 is negative 2. And then on the x's, we're going to add the exponents, 3 plus 1/3. Well, I need it to be a common denominator of thirds, so I need to change that 3 into 9/3. I'll do that right here. So 9/3 plus 1/3 would give us 10/3 for the exponent. And so it's negative 2x to the 10/3 exponent for the x. So that's our result for f times g. So now we're going to divide f divided by g. That'll be next. So f divided by g, so the negative x to the third is now on top. The 2, and I'm going to just go straight to this one. I'm just going to put that right underneath there and kind of bypass the cube root, because I already know that that's an x to the 1/3 exponent. So now at this point, we just want to simplify this if we can. And with the exponents on the x's, we can simplify them. There's more on top. 3 is more than 1/3, so we want to bring that to the top here, bring this x here up on top. And so it's going to be 3 minus 1/3 on top. So again, we're going to be changing that into 9/3 for the 3 minus 1/3, which will give us an 8/3 exponent for the x that's going to be on top. And so that lets us have a negative sign out in front of this. 2 will still be at the bottom there. This now moved to the top here. So we just have x on the top, and it's 8/3 that we got when we subtracted the exponents. So we're doing 3 minus 1/3. We're subtracting those exponents there, and so you can see how I'm doing it up on top here. And next thing is to state the domain. Now, we need to be careful on this one, because the domain for these has to be, it's kind of similar before, but there is a little bit of a twist for the one that's this division one, because at the bottom of any fraction you cannot have 0. So if there is a variable at the bottom, then it will not be allowed to equal 0. So we got to realize that and kind of account for that fact. So on this one here for the f times g, this function, so this would be a 10/3 exponent, so it's a cube root one here. This would actually be a cube root of this one. So it's going to go across here, across our graph. So on this one, the domain is going to be all real numbers, because it is going to go across the graph everywhere, both directions. This one here is also kind of a cube root function here on top. Cube root of this over 2. This one here, however, does have an x at the bottom when it's right here. So it does need to see that it just cannot be 0. So if it's a cube root and it does have an x down here at the bottom of the original function when we did this, so you're just going to have to say x cannot equal 0 on this one. So essentially that's just saying x can be everything except 0, because you have an x at the bottom of the original one right here. So if x is ever at the bottom on any stage, it just cannot equal 0. So next is the evaluation. So we're going to evaluate the f times g function now for negative 64. We're going to put the negative 64 in here, and so that will be looking kind of like this. I'm going to change that back into a root. So I'm going to make this a cube root, and then 10 is going to be my extra exponent for that. So it's the cube root of negative 64, because negative 64 is a perfect cube root. And so we could figure that out, raise it to the 10th power, and then multiply it by negative 2. So that's what we're going to be doing here. So the cube root of negative 64 is negative 4, and now negative 4 to the 10th power is going to give us a really big number. Since the power is even, we will get a positive from this. An even number of negatives will be positive. So basically 4 to the 10th is going to be this really big number. It's in the millions, 1,048,576. So 1048576. We're going to multiply that by negative 2 and make it even a little bigger. It's going to be a negative answer now. So negative 209 and then 7152. And then the next one, we'll do the same thing. We'll plug in the negative 64 in here on the top of this one. And we'll also make it a root of this one as well. So it's going to be the cube root of negative 64 again, but then raised to the 8th power. So we know that's going to be negative 4 now on top. And so the negative 4 to the 8th is also going to be a big number. So we can see that's going to be 65,536. We still have the negative outside. We're going to divide this by 2. It will be a negative answer as well. So it's going to be a negative 32,768 for this one when we divide that by 2. Again, you can be using your calculator for this. I expect you to do that. 4 to the 10th is not something you're going to be able to do in your head, of course. So go ahead, just use your calculator to be able to figure those out. Number 6, starting with f times g, we're going to multiply these two together. And so this is going to be these two times each other. So the 12 times the 11 will multiply. We're going to add the exponents. This is basically at 1 times a half. So 1 times a half, as you can see, I'm going to make a common denominator as out of the 1 of 2 over 2. So 2 over 2 plus 1/2 is going to give us 3 over 2. So that's what our exponent is going to be. So 12 times 11 is 132, and the exponent for x is 3 over 2. So that's all it is. So I know these might seem a little more difficult, but they really aren't that hard. Just multiply the big numbers up in front, and then on the exponents, you're going to add exponents when you're multiplying. And then for f divided by g, same idea there. So 12x is on the top, and the 11x, the negative or to the half, is there. On this one, our x's want to go together, so there's more on top because this is 1 and it's bigger than the 1/2. So again, we're going to move this one up top. So essentially, this is going to be 1 minus a half. Well, 1 minus a half is still a half. So we're just going to have an x to a 1/2 exponent on top with the 12. So it's going to be a 12. X to 1/2 is over the 11. So you always got to get the variables. You can't leave your answer with variable on top and bottom unless they're different variables. You can't leave the same x on top and bottom. You have to get those together. So always move the smaller one to where the bigger one is. And then we're going to do the domain again. For this one, it's a square root of this one. So our root really kind of tells us what it's going to be. This would be actually a square root for the fraction exponent, so it's only going to be going one direction, and it's going to go off to the right, which means it's going to be greater than or equal to 0. And the same thing is happening with this one. It's a square root as well, so it's going to be doing kind of the same thing. But since we did have an x eventually here, originally in the bottom, it also can't be 0. So it's almost like this one. It just can't be the equal to part. It will be greater than 0 though. It just won't be equal to 0. So it's going to be x is just greater than 0 on this one. And that's the reason why, is because over here there was an x at the bottom, and we said that you can never have 0 at the bottom of your fractions. So now you're going to evaluate for x equals 4. So you're going to put that into x here. And again, I would do a square root to start off with, a square root of 4, since 4 is a perfect square root. So I'm going to see it like this: 132 outside, square root of 4, and then raise it to that extra exponent. 3 is the extra exponent you're going to raise it to. So that's going to be 2 there. So we have a 2 to the 3rd power, and 2 to the 3rd power is 8. So 132 times 8, just again use your calculator for these, it's 1056. And then the next one, do the same idea. So we're going to put in, I do a square root here as well of the 4. So on top, 12 times the square root of 4, which we know that's 2. So it's going to be 12 times 2 on the top. So we'll have 24 over 11. And you can leave it that way as a fraction. You may need to, or if you need it to get to a decimal, just divide it, and it's about 2.18 as a decimal. Okay, now number 7, starting off with the f times g again. We're almost done. We just get 2 more of these. So f times g, and they're both got fraction exponents, but the roots are different, so we'll see how that plays out. So we're going to leave them as exponents right now, and they don't have to be the same roots on these ones, because we can still add these together. So we will multiply our numbers here, our bigger numbers, so the 0.25 times the -4, we'll multiply that. And if you do that on a calculator, you'll see that I did that right here, 0.25 just times 4, I'm going to get 1. So that's just 1 right there. So we're going to get a 1, it's going to be -1 in fact, and then as we add these, we're going to have to do a common denominator for the 3 and the 2, the denominators here, make them both into 6. So it'll look like this. This 1/3 will become a 2/6, the 3 over 2 becomes a 9/6, and now we're going to be just adding 2 and 9, giving us 11 over 6. So there's our answer, -1x, or negative x, you can just say, to the 11/6 exponent. And there it is for the f times g. And now we'll do the f divided by g, or f over g. And so we just put 1 on top, the f's on top, and the g functions on the bottom. So we want to see these here is divided now. So 0.25 divided by -4. And what I would do here is get them to become, get rid of this decimal here. I'd move this 2 places over here to make this a 25, and then add 2 zeros to that 4, making it 400. That'll be easier to simplify. That'll give us a 25 over a 400, and we can reduce that by 25. So 25 goes into itself once, and 25 goes into 416 times. So that lets us know that there's really just 1 on top with x up here, and then 16 down here with this x. And we do want to get these together. So where there is more x's, or where is the exponent bigger? We have a 1/3 exponent here, a 3 over 2 down below. So it is bigger down below, which means we want to move this one down here and subtract 3 over 2 minus 1/3 here. So I'll show you what that would look like. We're getting common denominators. So it's going to be it's basically the same idea as this. It's just now we're subtracting them. So we're subtracting this now. And actually what I'm seeing here, I would actually probably just do it this way, turn this around. I would say the 9 over 6 here minus the 2/6, and it's just at the bottom. So that's really what it is. I'm showing up here that you will get a negative exponent, which means you need to move it to the bottom. So we'll see that we're going to have to put the x's at the bottom. The 7/6 exponent's going to be at the bottom because this bigger one is down here, 3 over 2. So you're really moving this down here, making this 9 over 6 minus 2 over 6, which gives you 7 over 6 exponent. Okay. Up on top here, I got a negative 7/6. That's just if I moved it on top, it would be that. But it would be a negative exponent that I wouldn't want to keep there. I'd want to move it down below to make it a positive exponent for my answer. So we have the negative on the outside of this. 1's on top. That's the only thing left. Is just the 1. 16 is the big number with the x to the 7/6 power. Okay, now as far as the domain, we'll see on this one, for a domain, this is a 6th power and even roots going one direction. So this is going to go just one direction. But the negative is out in front. It's not actually in a parenthesis here with x, so it's not affected by that. So it still is going to the right. So that you wouldn't put the whole radical here with the negative underneath. This negative would still be in front of the radical sign, still allowing the radical or this root function to go to the right, which means it's going to be still greater than or equal to 0. These are all going to be 0 because you can see with x there is no h number. It's going to change from 0 if there is an h number. If it was in a parenthesis x plus 1 to this 11/6 or something like that, then it would change. But if it's just x, it's always going to be 0. For our problem down here, it is also the 6th root, but you can see it's at the bottom of this. And so what we'd want to notice here on this one, it's going to be x is greater than or equal to 0 on this one, or not equal to, just x is greater than 0. Can't be equal to, because x can't equal 0 when it's on the bottom. And actually, before I get to number 8, we still have to do the evaluation. So x equals 1, we're going to plug that in for x in both places, so just 1's going in. 1's a perfect every root, so that will be easy. I'm going to put it in our root sign here, making this the 6th root of 1, and then the extra exponent from the top there, 11. We'll do that afterwards. So the 6th root of 1 is still 1, and then we'll see 1 to the 11th power. That's still 1, and then just 1 times a negative, so the answer is -1 for this one. So the f times g, when you evaluate 1, is -1. And when we do the next one, we'll plug that in just down below here. It'll be the 6th root of 1 and then raised to the 7th power afterwards. That's the numerator here. So again, this is 1, and 1 to the 7th, we'll see, well, that will be 1. And so now it's just going to be 16 times 1. So 16 times 1 is still 16. So it's just a -1/16 then as the answer for this one. Okay, number 8, starting with the f times g. So we'll multiply these together. So that's going to be f with the 7/4 exponent, and the g1 is with the 1/2 exponent. We're going to multiply 36 times 4, the big numbers. Just you use a calculator, or just you may know that one. So 36 times 4 for the big number. 7/4, 1/2. We do need to make this into a fourth here, because 2 can go into 4. So this will become a 2/4. So it would look like this here, 7/4 plus 2/4, making us 9/4. And there's the exponent for x. So it's just going to be 144, that's the 36 times 4, x to a 9/4 exponent. And the f divided by g, f over g. So top one there, 36, the 4 is on the bottom. We can reduce these numbers, so they both can be reduced by 4, so this will go to become a 1, and this will become a 9. 4 goes into 36 9 times. It is bigger on top. 7/4 is bigger than 1/2, so we're going to move this up here and subtract the 1/2 from this. So 7/4 minus 2/4 this time. 7 minus 2 will be 5/4. So the exponent's going to be 5/4 on the top for this one. And so we're going to see 9x to the 5/4 is going to be over 1, because remember the 4 went to 1, 4 became 1, and this moved, the x on the top. So everything is now gone. It would just become a 1, and we don't need the 1 at the bottom of any fraction. We can just say 9x to the 5/4 power now. The domain for our top one, it is an even root function, so it's going to have the same kind of domain as this one. X is greater than or equal to 0. Again, x has no h, so it's still 0. So just x is greater than or equal to 0. This one, it's again similar to this one here, because it did have the x at the bottom, so we cannot say it can't equal 0, but it can be greater than 0. So this one's just going to be x is greater than 0, because it is a 4th root function. It just can't equal 0 because it did have an x at the bottom of a fraction here. And then the evaluation, we're evaluating for 16. We're going to plug 16 into these, and 16 is a perfect 4th root, so that makes it nice. So we're going to again make this a radical with the fraction exponent. So it's the root is 4, your extra exponent is 9, so it's the 4th root of 16, then raised to the 9th power, and then multiplying by 144. That's the order that you would do this in. So the 4th root of 16 is 2, and then 2 to the 9th power, if you just keep multiplying 2 9 times, that's going to give you 512, and then 144 times 512, it's going to be a fairly big number, 73,728. And for this one here, again, do the 4th root. So it's the 4th root of 16, again, raised to the 5th power afterwards. That's my numerator, and then we'll multiply by the 9. So again, that makes this 2. And this will see 2 to the 5th power, and multiplying 2 times itself 5 times, that's 32. And then 32 times 9 will give us our answer number, which is 288. Okay, problem 9 on 147. This one's a little different, but you know, it's the same thing that we've been doing. F plus g, f minus g is what it's saying here. So it gives us the graphs of these two functions. For here, actually it gives us the graph. Here's our functions here. The quadratic one, so there's the quadratic one. It gives us this one, which is a linear function. right there. A lot of times we do see functions on the same graph. A lot of times we're looking for where the intersecting point is, which would be right there if we were to find that. But on this one, we're actually trying to figure out what graph would be the f plus g and which one's going to be the f minus g as you combine these together. And if you add them and subtract them, what kind of function will that be? As you can see, they're both going to be quadratics, but just which one will it be? So if we did the f plus g, it's just going to be adding them together, combining like terms. So eventually we'll cancel out here the 4x's. Those will both cancel out. So we'll see an x squared and then just positive 4 and negative 5. That'll become negative 1. So as you can see, that one's going to be b over here, which means that this one should be a f minus g. So f minus g, if I go ahead and subtract them with the parenthesis around the g, and then change the signs here. So I'll make this into addition, and these will be become their opposites that are in the parenthesis. So this becomes negative 4x and positive 5. We still have an x squared. Our negative 4x and negative 4x would make the negative 8x, and then 4 plus 5 would give us 9. So there's that one, which is the same as this one down here, as you can see. So that definitely tells us which one is which. F minus g is this one down here. Those match up. And this one is f plus g here. So we can also do this if you wanted to. B is f plus g is b, and f minus g is a. Okay, we have arrived. Here's our last problem. One's a little bit different here. It's a bit of a word problem. So the variable x represents the number of pages of a textbook to be printed. The cost c to print the textbook can be modeled by the equation c of x is equal to 0.2x squared plus 10. The selling price p of the textbook can be modeled by the equation p of x equals 0.05x squared plus 20. A says find p minus c. So we want our functions are p and c this time. We're going to be doing p minus c. So this function minus that function. So the second function, the c function, is the one that's going to have to be in a parenthesis because we are subtracting this one. So we'll put that into parentheses here for the c. So start off with writing p down, 0.05x squared plus 20 minus, and then in parentheses put this c function down. It'll look like this. So there's our p function, and put minus, and then in parentheses here, 0.2x squared, then it's plus 10. So I'm changing the signs again. I'm distributing this. I'm making this a positive now into a plus. This becomes a negative 0.2. This becomes a negative 10. And so now we just combine the like terms here with the x squareds together. So 0.05 and 0.2, those combine. That's going to give us a 0.15, actually negative 0.15, because this is like 0.20, and this is like 0.05. So basically like 20 cents minus 5 cents would be 15 cents, but it is negative because it's a negative 0.20 here. And then 20 minus 10 would give us 10, so plus the 10. So that's the function, that's p minus c. It says explain what that means. What does it represent? So what that basically represents, if we think of, okay, you have the p, the selling price minus the cost, what would that actually be? Well, that's how much they would actually make for selling these textbooks. So this is the selling price, so they're going to sell it for more than it costs. So if they deduct the cost out of the selling price, what's left is the money they walk away with, which we call a profit. So it represents the profit for selling the textbooks. That's what profit means, the money you walk away with after you've sold it. All right, so that concludes 5.5, and I guess I'll see you in class again.